Okay, let's get going. Python. So who here has used Python before? Okay, good amount of people. What for? Research, a class. We don't teach that in our department. CS, I don't know if CS teaches that ever. Just for fun. What was that? Oh, competitive program. Okay, cool.
Like server scripts and stuff like that, like sysadmin type stuff.
Okay, awesome. Well, no problem if you haven't ever even heard of Python. My son is super into snakes. And so anytime I mention the Python programming language, he's like, oh, what? Python? Like, it's not as cool as you think, I promise. There's no snakes involved in the program. Okay. All right. I figured to keep with tradition of my other lecture, I should show you a comic to help motivate the awesomeness of Python. And I truly believe in this comic. I love Python. Probably my most favorite thing to talk about, maybe besides like networking. Okay, Python. It says, you're flying, how? Python. I learned it last night. Everything is so simple. Hello world is just print hello world. And this is Python 2. Now you have to put parentheses, so it just doesn't know. I don't know, dynamic typing, white space. Come on, come join us. Programming is fun again. It's a whole new world up here. But how are you flying? I just typed import anti-gravity. That's it. I also sampled everything in the medicine cabinet for comparison. But I think it's the Python. Python is very magical. Import anti-gravity. Science could be that simple, that magical. You just find the perfect library that you need to solve all your problems. You import it and just like, wow, it just like works. And that's, so I love Python. I think it's a very powerful programming language. I think it's a good mixture of lots of different traits that makes it easy to use, but also powerful enough to grow with you. It's not always the right tool. You gotta always choose the right tool for the right job. But I think a lot of people discount Python maybe because it's not fast enough for, when they should actually be using it. So to continue with the motivation for this, why Python? Why not another language? Anyone have any thoughts on that? Like, what languages do we know? C, right? C++. Do you learn Java now ever? Yeah. You learn Java. So why Python? And sorry, did you have your hand up before that, or?
Yeah. I feel like Python just like it's becoming more and more popular. Like I looked on like and usually like C++ and Python for a lot of engineering stuff. I think it's partly just because it's flexible. Like there's a lot of really good libraries in there. It's pretty simple to use. Just kind of started to become a little bit more ubiquitous.
Yeah, definitely. And I find it quite interesting the trends of programming languages. That's that's a more longer arc than this, but Python's been around for a while, but it's kind of built popularity only somewhat recently. I mean, it's been around for a long time and it's been popular in its own right, but it's starting to pick up for a couple of reasons. Yeah.
If you already know general programming stuff, it's really easy to like dive into and learn real quick, or to come back to if you haven't done it in a while. You can easily like relearn the basics and get going into it again. And it's kind of becoming that like Swiss Army knife glue scripting language.
Yeah.
Scripting languages, like you still see a lot of like Ruby and occasionally Perl and other things out there, but Python's kind of starting to dominate it, which is not always the best thing, but it's a good language. And yeah, it's kind of establishing itself as like a standard. So
yeah, I like that. And you both hit on an interesting point that I want to highlight. And my process to try to convert you all into, I think the terms of Pythonista. I actually don't like that term, so I'm not going to use that. But that's actually what turned you into Python lovers is ease of use. Isn't that so important? To to be able to take some code and hand it to someone else and they understand relatively quickly what that code's trying to do without having to remember where pointers work and all this hidden details that come in with other languages. Or maybe yourself in your future self in a month. You're like, wait, what was I thinking here? So ease of use is a very important thing. You think of your time being a precious resource and that costs a lot of money and that you can't ever get back. Then ease of use should be a really high priority, because if you can save time building something, maybe it's not the fastest, maybe it takes a couple of seconds longer to execute. But if it takes you hours less to understand or to write it, then isn't that a way better improvement? So I think Python, for that reason alone, is worth learning just because of its easy use. It becomes a Swiss Army knife. Rather than, oh, I should do this in Bash, a Bash script. No, just do it in Python. Python becomes almost a a cure-all for any problem. At least you start there, and then if it outgrows it, then you move to something else if you need to. But I think there's other important reasons to learn Python. There's been I think this is partly why it's so popular now, is the movement of this data analytics tools, things like NumPy and pandas. And if you don't know any of these terms, that's totally fine. Dr. Mingoson will be talking about that in 2 lectures.
And in Conda? Or?
Oh, no, I thought you were going to talk about pandas.
and NumPy, right?
NumPy, right?
Yes, we are. On Friday, yes.
So you'll learn about what those weird words mean, but those are very powerful, important libraries. And so Dr. Mingoson will be talking about that. There's other things, PyTorch, these are machine learning, scikit-learn. There's tons of, TensorFlow now has support for Python as well. So a lot of machine learning work going on there as well. So if you're ever getting involved with machine learning, often Python is a good place to start. It's not always the best place to end, but it's a good place to start. One more thing I want to add to that. Okay, no, actually a few more things. I think it scales from quick scripts of you just start with open file, you can quickly write some lines and do something. It can scale up to where you add more and more complexity to your code as you need it. So it can start out as just a simple idea and move all the way up into a full-blown application you want it to. The standard library, they call this, I don't know, anyone heard this term, batteries included? Kind of a weird thing for a programming language, but it's a term that they use consistently. Batteries included. Python has batteries included. You don't have to download a bunch of stuff to use it. You can, the standard library, the thing that comes with Python, is pretty full featured. And so you can actually get a lot done with batteries included. You don't need to go get batteries somewhere else. And then there's a lot of amazing packages as well. I would say it's become a habit, as engineers, like, okay, like, oh, I gotta do this thing. Let me go write it real quick. Write this routine to do something. I've tried to get into my head where, no, you don't write it first. Don't write first, ask questions later. You first Google it and then find the person that wrote the code for Python, and then you import it. There's just so many obscure things out there that people have written for Python, and just it's as simple as import anti-gravity, and then it just works. Not always. Sometimes there's bugs in it or whatever, but it's often a good place to start. Is actually just doing a Google search and see if someone else has written that module for you, and then you start. Okay, what have you heard about Python not being not using Python? Any reason demotivators for Python? Yeah.
I've heard that the benefits of abstraction comes at a cost of overhead.
Overhead, okay. So what kind of overhead are you referring to? Or sorry, I'm not trying to put you on the spot. I agree, but I'm just you.
I recently did some research. There's this GIL thing that prevents multi-threading, and also that it translates Python in real time, and there's a little bit of overhead in that, I think.
Yeah. So yeah, you're referring to the GIL, Global Interpreter Lock. Yeah. So even if you write things, your multi-threaded computer, it actually, Python does not do very well with multi-threading. It never can have multiple threads running at once because of the Global Interpreter Lock, which is a blessing and a curse. Curse for performance, blessing for simplicity, and some, don't have a lot of bugs when it's dealing with threads. Yeah, so overhead though, I like what you said about that overhead. I mean, there's the performance overhead. I think that's a big criticism of Python. It's just not maybe fast enough. You have to do this translation because it's all at the end of the day implemented in C most of the time. And there are JSON implemented JavaScript and other one, or not JavaScript, Java. But often it's written in C. And so yeah, there's a penalty you have to pay for translating from Python world down into the C world. And so you do have overhead there, definitely. I might come back to that. Is this figure? This is top of my programming joke list right here. So this is from Dropbox, which is a big Python shop. They actually employed the creator of Python for quite some time. So the rules of performance, improvements. You can like this. First step is just don't do it. Don't ever try to improve the performance unless you really have to. So that's your first step. And the second step is to cache it. So store it persistently, and you can just pull that out rather than recalculating things. Third, you batch it. Fourth, you pipeline it. Finally, fifth, don't do it in Python. And so they obviously have a strong belief in Python that often Python's not the problem here if you have a performance issue. There's a lot of other things you can do along the way. So though Python is slower than something like C, I think there's a lot of other things you can do to speed up Python. And if you write your Python code correctly, or if you use libraries like pandas or NumPy that are optimized for certain operations, very, to be very quick, then often you can get away with just using Python. But if you do all these things and still Python doesn't work, then yeah, then it's not the right tool for the job, and you need to move on to something faster. Let's see. Any other thoughts on reasons not to use Python? Yeah. Yeah.
Python does it all on its own, but if you have pretty limited amounts of memory or storage or processing power, it's like having C++ where you can specifically dictate, what's getting stored, what's not getting stored. Python just does it all automatically.
Yeah, definitely. So you give up some amount of control. Once again, I talked about this last time I lectured that, you become an old man and you are an old person, old man or woman, you get lazier and you just like, don't make me work hard. I'm in that Python, like, yeah, I don't want to control my own memory. Please don't make me control my own memory. Like, I'll mess up. I promise I will. If I have to, if I have a task that I need to, then yeah, you got to do it. But often just let Python deal with it and it'll do a way better job than I will. But yeah, sometimes choosing the right tool for the right job, you have to. If you need that control, then there's no way around it. You got to use another language. Or there's no maybe easy way around it. One issue I feel like that's maybe if you aren't into Python, you don't know this, is the Python versions. I did want to highlight that. So there was a transition. I think we're out of it. People that use Python, do you agree? Or are we out of the woods yet? There was a transition between Python 2 and Python 3. And it was a very painful transition. And you download a library, which one does it support, 2 or 3? And they're not backwards compatible, 2 and 3. There are some issues. There are ways to port it over, but it doesn't work very well. But we're now deep into Python 3. So I think we're out of the woods. You still will find some libraries that are in Python 2 only.
Don't use them.
Just don't use them. Yeah, there you go. But that is the issue. So I would suggest for anyone that's learning Python, you should use definitely Python 3 and don't ever touch Python 2 unless you really have to. But I would even suggest Python 3.7 and above. 3.2 has weird issues as well. 3.3 is not great. I think 3.5 is where it started getting a little bit better. And then I would say 3.7, 3.8 even. I mean, probably the best version you can. I don't know. Do you guys have any thoughts on that for your research? You use the latest version?
I'm on 3.8 and I haven't had an excuse to go to 3.9 yet, but once I do, I'll go to 3.9.
Okay.
3.7 bare minimum.
Yeah, 3.7 bare minimum. And I will say for this assignment for this week, don't mess with your Python version. So if you just so happen to have Python 2 only on your computer, I mean, you probably should have Python 3 if you have a modern computer, but don't mess with it. Just do the assignment and don't worry about it. Dr. Nelson will talk about how to get your Python environment right in the right Python version on Wednesday. And so I don't want you messing with that until he talks about it. He shows you kind of how. If you know what you're doing, then sure, but
Machine if you do it wrong.
yeah, I can really mess
We
up.
all have done that.
Yes. In fact, relate to that, what Python version, and another issue I feel like with Python is its package management. I think it's important to be consistent. Dr. Nelson will show you how to be consistent, but it can be kind of a mess. And it's good when there's actually an XKCD comic about that as well. 1987. This is your Python environment. And it's a joke, but it's actually not that much of a joke because my computer probably is literally like this. There's all these different ways of installing Python. Here we got, and then different packages. You got pip, which is a package manager, but that used to be easy install. And then you got Anaconda. You got Homebrew, which is a Mac specific thing, but different versions. And you download it from python.org, and directly there's this. It can be all a mess, and they're all in different paths, and you got to figure out the right one. It can be a huge mess to try to deal with this, and so try to avoid that if you can. And like I said, Dr. Nelson will really show you how to kind of avoid a lot of these issues. But this is a
That
problem.
seems simpler than usual. I don't know.
That seems simple. I know.
Yeah, I find that very helpful, actually.
And I have kind of ways of figuring out this stuff. I don't know if it's the right way, but so my Python environment has become so degraded that my laptop has been declared a super fun site. It's just such a mess. Yeah, so be consistent in how you set things up and set up virtual environments. And you should talk about that next lecture. Okay. Let's see, very good. Okay, anything else about Python that people want to air, pros or cons for Python. I think it's a great, important language to learn. You're going to face it, I think, at some point in your careers. So I think it's good to just learn it now and just embrace it. I'm biased. I don't know if anyone maybe wants to counter my excitement for Python. I love Python. You're going to counter me?
I don't think you're excited enough.
Oh,
I'm more excited than you.
oh really? Okay. Yes.
I love Python. I think it's great as well. But I also don't think it should be like the only scripting language people should know. I think it's a good base, but I think people should still make sure they know basics of Bash scripting and maybe at least like one other scripting language, just to have a little bit more literacy than just knowing Python and doing it all the time. But that's just
That's fair. That's fair. It's good to be well-rounded and not get stuck into things too much.
you might find times where like those other options are the more ideal solution. So
Usually if it's written in another language, I just rewrite it.
What I love about Python and what's kept me around so much is its simplicity, ease of use, but its depth. You can get really deep. I remember, what class was it? I can't remember. It was CS department here at BYU. We learned about Java reflection. Anyone know what Java reflection is? I barely know what it is, but essentially it lets you load in, like, you can load essentially a file and run it in and bring it into your environment. So you can essentially inspect objects and figure out what methods they have on them. There's this whole API for how to do that. And it's really, as Java is, clunky and hard to use. What I love that is Python makes that easy. You can just do so many crazy things that you probably shouldn't be able to do, but you can. And that excites me and makes me love that there's depth to it. It's not just a very simple language. There's a lot of depth to it, even though it gets kind of a wrap of being just a really quick language for beginners. There's a lot of depth. If you're ever interested, go look at those. PyCon is a conference every year for Python. Go look at those talks, and there's some crazy stuff that will blow your mind about how it works. Okay, so I want to introduce you to Python. This is by no means going to be a comprehensive introduction because we don't have time for that. It's go find a tutorial, a YouTube video, whatever you want to learn the specifics of it. You'll see some specifics of it as we go through, but I just came up with a list of things I thought might be helpful for people to learn. Gotchas, kind of weird issues with Python, because it does have its warts. It's not by any means a perfect language. But I want to show you those things. So we'll go through that stuff. Please stop me if you have any questions or if you want me to try out anything, we can do that. So the first thing I want to point out is what's called a REPL. Anyone heard that term before? REPL. Anyone know what that stands for? This is a thing that you'll see often with interpreted languages. You don't see that with C because it's compiled. Interpreted languages, it's the read, evaluate, print loop, REPL. So it lets you, so if I run Python, let's just make sure what version, okay, 3.8, that's what I'm on right now. If I run Python, I get brought into the REPL right here. So it's saying, hey, what do you want to type in? So you can type in anything, I don't know, one. But what it does is it reads the input, evaluates it and prints it out and then goes on to the next thing. So that's the loop, it loops forever. So that's the REPL. And that can be handy. I honestly actually don't use it very often, but it can be nice if you just like, wait, why is this not working? And just quickly bring up the REPL and try out some things like, okay, what happens if I do int cast a 5 string to an int? What does that do? Oh, okay, it converts it. Great. So you can kind of verify things like that. And for a beginner, it can be kind of helpful as well. So that's the REPL. A couple of helpful things with regards to the REPL is if let's say, there's a built-in function called help, help 5. So what it did, I passed it an integer and it tells me an int. It gives me help information about it. It's pretty intense, so often I don't do this, but if you're really stuck, you can just type in an object like help and then the object, and it'll give you details about that object. And you could of course do this with like, with the actual variable name as well. You'll figure out that it's in as well. Okay, so that's one thing, but I think more helpful is the command dir. Dir, sorry, that's kind of low. Is that big enough for everyone? Back there, can you see it all right, or do you want me to make it bigger? You want me to keep it up higher, or can you see it low? So dir is a helpful command. This will tell you what kind of methods can you call on this object. So let's do 5 again, dir. So it gives you a list. It's not pretty by any means, but it tells you all the things. So an integer, you can call so many things on it. And these are all kind of a weird notation. Double underscore. Python, this is a common notation for Python. They have a name for it. It's called a dunder, double underscore, a dunder. And that typically means it's something internal to Python, and usually you shouldn't be messing with it unless you know what you're doing. So I know that it's there, but you don't have to know how it works. But you got some things like 2 bytes. Let's try that. So we can do 5.2 bytes. And I actually don't know what this is going to do. Syntax error. Length.
Can you do 2 bytes 5?
What?
Pass the 5 into 2 bytes.
Say that again?
Can you pass 5 into 2 bytes instead of?
Okay. 2 bytes is not defined. Okay, well, that's what I get for trying to do stuff in real time. So that works. I mean, we'll have to figure that out.
Test.2 bytes?
What?
Test.2 bytes, because you signed test to 5, right?
That's built in.
I think you have to give it a number.
Oh, you have to tell it how many bytes you want in Python, like when you do the 2 bytes.
Okay, so that serves me right for not knowing what the function does. Okay, well, I'm not passing their parameters. Anyways, that's not the point. I'm gonna quickly clear this out. Forget that ever happened. Stick to my list, right? Okay, so now, one thing I like, Python itself is a funny name, right? Anyone know where the name Python came from? Yeah,
Monty Python?
Monty Python, and the Holy Grail, or not the Holy Grail, Monty Python, sorry, but we all know. A lot of us know. So there's some amount of comedy to Python itself, jovialness involved with it. For example, you can actually do import. This is part of the language, anti-gravity. And it brings up the XKCD comment for you. So someone in the standard library and made this module that did this for you. I like that. I mean, it's silly, who cares? But it's like, it's real. Okay, how about this one? You can do. There used to be when you're transitioning from Python 2 to Python 3, there used to be this weird syntax where you do from future import. You would kind of say like, I'm in Python 2, but I want to import some of the new features of Python 3. So you do from future import braces. If you haven't known yet, Python has no braces in it. It's all white space dependent. So you hit this. Oh, did I have that wrong? Oh, dang it.
There's no future in Python 2, is there?
Yeah, no, there is. I just know
No,
there
there
is.
isn't.
Syntax error. Not a chance. So someone wrote a custom exception for import braces. This got converted into Markdown for me. That's why, which is bold. That's why I wrote it wrong. Yeah, so someone wrote a syntax, a special error for, we're not ever going to have braces in our code. I just think that's funny. Okay, last one, import this. It'll show you what's called the Zen of Python. So someone wrote this, Tim Peters, the Zen of Python, and it's a great thing to read. We won't read it here, but it's got some good stuff in there. Whether you agree with it or not is up to you, but I like it. But okay, to this point, it brings up an interesting thing that Python itself has a certain style to it, which I enjoy that style. They often call it Pythonic. Is this Pythonic? And so that's a question that you might consider asking yourself. I mean, as a beginner, maybe who cares? Just write the code and get it to work. But eventually, you get to the point where you say, well, is this how a good Python programmer would write this? Because Python has certain idioms, it has certain styles, and so getting it to its true form of what it is to be Python is Pythonic. And so I feel like this goes along with it. That Python, it's not just a programming language; it's a community. It's a way of life. Not really. I think it too far, but it's a kind of a style thing. And so I feel like that is an interesting thing, and that's actually honestly a good lesson for learning any programming language, in my opinion, is trying to find the style of that programming language that you're writing in. For example, Java uses camel case, right? And there's nothing stopping you in Python from using camel case, but they don't use that. They use underscores to denote between different things. And so trying to find the way of writing, I think that can almost make it a little harder. And I enjoy that kind of adding the hardness. It's not just writing the programming language, it's writing in the way that Someone that only knew that programming language would write it. So it's kind of fun to switch. Okay, in C, I need to do it this way. In Java, I need to do it this way. Okay, and trying to understand the actual community that you're writing the language in. Okay. Any questions so far? Zen and Python, you're all happy with that? Okay, so let's talk about the basic data types. Shouldn't be too surprising, but we got a string. Huh, that's interesting. You can tell right here, there's no char character like you're used to in C. You can use single quotes or double quotes. They are equivalent to each other. You'll see later on my formatter actually converts them all into double quotes, just for consistency reason. But they're equivalent in Python. Numbers, simple enough. Nice thing about it is you don't have types, which we'll get to in a little bit. So you can have very large numbers, and Python will handle that. Overflow and worry about it. I don't know exactly what's being used under the hood in terms of object type.
I think there are types, but it automatically interprets which ones it should use.
Yeah, and then it can grow, I think, very big. This is a newish feature of Python. And that's something I actually really like is they have this separator. So that's, you can put underscore in your number to separate out however you want to. So it's kind of handy. It's not it doesn't mean anything about the actual number. It's just for human reference.
With the quotes and single quotes, can one be used to nest in the other?
Yes.
Is that how the single quotes are used versus the doubles?
Yeah. So, yeah. This is a test like that. Okay. Yeah. Well, I mean, it wouldn't work to do that because then that would be leaving the string.
For that, can you just use the backslash to escape them? Does that also work?
That also works. Okay. That's why, I don't know if you saw in the Zen of Python, what does it say? Something about there should only be one clear way of doing it. Sometimes I feel like Python violates that rule because there's 100 ways of doing it in Python. And you just ever search Stack Overflow, you'll see like, what's the best way of doing this? And then people have time it, they'll time how fast each method is. And so it's like, I don't know if we're really following this, this rule of like, there's one clear way of doing it. But whatever. So yeah, having multiple different quotes is, and then I wasn't going to mention this, I guess, but there's also the triple quote as well. And that has some meaning as well. But for our purposes, it's just a quote.
Is that for doing the multi-line?
Yeah, multi-line stuff. Yep. Okay. So numbers. Okay, so let me go back to the separators real quick. So I just find that handy. That's actually a new feature. So you can, make really large numbers and it just helps you represent, understand what it is. But Python doesn't care. It just ignores the underscores. Okay, we got lists. And I'm only going to cover the data types that are built into Python kind of natively without having to import anything like that. There's a lot of other data types if you want to import stuff. There's lists. That's how you do a list. So 1, 2, 3. You don't have to create a new object or anything like that. It's just built in like that with square brackets. So let's see. Let's do a list is equal to 1, 2, 3. So to access various parts, we can do that. That gives us the first element. You can set it equal to various things, list. Okay, great. That is what you'd expect for a list. This maybe is refreshingly simple if you're used to other languages, but if you're used to scripting, then this is kind of par for the course, I'd say. There's a tuple. I used to pronounce a tuple. I don't know who pronounces a tuple. I don't know what's the right way of saying it. I say tuple. Anyone familiar with a tuple? Okay. So that's in Python, that's denoted with the parentheses. For a lot of reasons, it's actually the same as a list. Important reason in Python, at least, is that it's immutable. You can't change it after the fact. So up here, we changed the first element to 5 and we printed out it worked. If we do, okay, let's get the 0th element. Good, that's what we expect. Let's change it to 5. Here we'll get an error. It does not support semi operators. So once you create that tuple, it's set in stone. You can't change it. You can't modify it. It's immutable. So that'll get you. It gets everyone at some point. Like, wait, what's going on here? And you're dealing with a tuple. Dictionaries are also very simple. They're just with the curly braces. So that's a dictionary right there. But what you'd expect, key value pairs. So like 1, test, 2, bar. Yeah, we got our list, our dictionary. And then to get stuff out of it, let's do. Get stuff out of it. Okay, simple enough. One more thing that's a little bit more hidden, I would say, is sets. That one you actually have to type letters. Ugh. So it's just that. That's built in as well. So sets are useful. You know, if you set 1, 2, 3, and then 1 again, it will just get you unique stuff. It looks a lot like a dictionary. So that might get you. It's like, what? How is this different? This is key value, key : value, whereas it uses a curly, but it's just values when it prints out. But to create it, you set. Okay, any questions so far? Yes.
Lists and tuples don't have to have all their elements be of the same type. Is that true?
Yes, that's true. Yes, we're going to talk about that dynamic typing, but I love that. I forget that that's actually a thing.
I know, I do
Like,
too.
why would it not be able to have lots of different types? But you know, in strict languages, stack typing, yeah. So we can do, and once you get used to this, you can't go back. I don't know what other types.
Floating point or something, list to list.
Throw a dictionary in there. No.
I mean, yeah, let's just go crazy, you know, and so there, we got this mixed type. So yeah, you don't need a list of just integers or just strings. You can have a list of whatever you want, and that's the beauty of it. Float. Okay, one more thing. Sorry, Boolean. We didn't talk about Boolean. A bool. Now, the important thing with that and the annoying thing is it's capitalized. True. Has to be capitalized. So true is true. False. Those are Booleans, but they're capitalized, which is weird. I still don't love that. But yes, you can mix types. So I mean, we can put in here. Go back up. False. I don't know. Whatever you want. So anything can have mixed types, and it's so great. So like if you have a function you want to return lots of values, you can return a tuple of success code. It was not successful, and a return value. I don't know why you want to do that, but you can return that. You know, and you can. Okay, one more type. It's the none type. And that's just the fancy word for null, I guess. I don't know, in Python, it's none instead of null, or nil in JavaScript. So yeah, just none, capital N. That's the other type. Okay, any other questions or thoughts people have about this? Yeah. Oh, yes. Okay, let's talk about that. Yeah, so I have a list here. So list, let's just show you, okay, sorry. That was weird. Okay, so we got the 0th element, 1, 2, 3, you know, but we can say, well, let's go the -1 element. That gives me the last element in my array. Let's go to the -2th element. Yeah, so that's very nice. You can go backwards, and then even have things like.
What happens if you go outside of bounds?
Side fault.
It goes in there.
So that's true.
You don't like side faults?
Yeah, so if you ever go out of the range, it throws an error. That's good. Another maybe helpful thing, I don't know, maybe this is too advanced, but you can also do slicing. So you can be like, give me the 2nd and the 3rd element, 2nd to the 3rd, and so you can, you know, so that's kind of nice. Well, I'm out of elements. This is kind of a strange thing. When you do slicing, you can go out of range. So that, and then, I mean, this could get crazy. You can actually do every other after that. I mean, is it this, where like, give me the 1st to the 3rd and skip every other. I mean, it's really powerful Python and what you can do, but let's not worry about that now. Okay, any other things you want to look at or helpful hints for people?
Are you doing comparisons in your script?
Yes, I'll talk about that in a second. Thank you. Yeah, the REPL makes me nervous. I don't know. I don't really like it. It's like it's. So let's go back to the real world of where I can hit Control S and save. Okay, let's start. Okay, so one thing I want to talk about. One important thing about Python, and it'll get you when you first write Python, is it's white space dependent. People know what I mean by that. So braces in the C type languages protect you, and that right? You can do whatever you want with white space as long as you have the braces, you know, around the block of code. Python's not like that. You have to have new lines. You have to have indentation in various places for it to work. So let's see. Let's say num5 if num is equal to 0. What's that doing right there? What am I doing? Modulo 2 equals 0. What's that checking for? What?
Even.
Good. And a good IDE, a good text editor will help you with this stuff. So, so make sure you invest time in that. Don't do this in TextEdit or, you know, or that's a Mac thing. Don't do it in Notepad. You know, do it in a good IDE that knows that you're actually typing Python, because it'll help you out a lot.
And tabs and spaces are different.
Yes, let's talk about that. So, okay, so this is let's run this. Just make sure it actually works. Good. 5 is on. Everything's right in the world. You'll see this. I have right now what's a formatter going on. Every time I hit save, it'll format my code. So you'll see that. So if I do that, I just hit save, and there's a certain style guide it's trying to follow, and so it will kind of correct things for you. One more example is, like I mentioned, single quotes. That's totally valid Python. In fact, let's run it without the formatter. Hit save, so it still works. But if I hit save, it's a no. You don't want to use single quotes.
So how do you run it without saving it?
There's a special command. No, the special command in VS Code, command K and an S to save without running formatters.
Oh, I knew it was worth coming today.
There you go. So yeah, I mean, if I, anyway, so that's a
What formatter do you use, black or?
black. There's lots of formatters. I use black Python formatter.
Black's made by the Python people, so I assume it's the best one.
I like it because it's just a clever name. Any color you like. I mean, you know that Ford reference, any Ford, that you can have any color car you want as long as it's black. You can have any code type you want as long as it's formed exactly like this. I used to be very particular. I handcrafted my Python code very carefully. Just I had the right format and everyone else was wrong, or the few select people that I copied were right. But then life's too short, and you just got to move on. And for black, in my opinion, gets it right most of the time. There are some weirdies I don't like, but just I've got too much to do. I don't want to be dealing with indentations and new lines. So I think one of the best things you can do is just download black or a formatter like it, and just let it take complete control of your life and let it format everything, because your code will be better, be clear for people. It's better.
I was gonna say, if you ever just want some entertainment, you can go to the Black GitHub and look at the issue tracker, and someone will open issue. I don't agree with how you do this, and you should close. We're not doing that. Closed. We're not doing that. Closed. Too bad. It's basically just it says uncompromising because they're going to decide how it's done, and they're not going to change it. So.
I like that.
It's okay because it's a good format.
It's a good format, and just yeah. I mean, maybe that's a rite of passage. Maybe when you get old, man, then you not care about this. But maybe when you're young, you have lots of time. You say, "Oh yeah, I want it just the way I want it." That's fine. But I suggest you use this.
They're putting a tab into those.
I can't. I don't even know how. So my IDE is smart enough that when I hit the tab thing, it inserts 4 spaces for me.
You have to open a makefile and copy and paste the file.
Okay, so that, Josh brought this once, and he brought up again. This very important point is tabs are different than spaces, and that will really ruin your day, because you get some code from someone else and you trust them. You think they're a good programmer, and then they use tabs. You're like an animal. How dare you use tabs? You're supposed to use spaces. No, I'm just kidding.
It can work with tabs, but only if you always use tabs.
You all know that it's a debate, right? Programmers love to debate things that don't matter at all. Formatting being one of those things. Tabs versus spaces being the other thing. Which one's better?
Tabs, then you'll put a few spaces in and
I'm on team spaces, but you can't mix them is the key here. You can do
I guess I missed this from my tutorial, but if someone has mixed them in your document, you can click that little button at the bottom and fix it.
Yes,
So
you can.
which one?
Most editors
the
will
spaces
replace
to the left of there,
Oh yeah, okay.
and either of those menu things will make it consistent. So
Yes. So mine's smart enough that it knows 4 spaces is the magical number, and if I hit tab, it means, oh, you really meant 4 spaces instead of a tab. So yeah, just choose spaces, because that's the.
I think it goes off of whatever looks to be the consistent spacing at the beginning of so if somebody did their Python using 2 spaces, it will expect everything to have 2 space indentation or something like that.
It will.
It goes off whatever's.
See multiples of the first indentation or something like that.
I think 4 is usually pretty standard.
Yeah, so I mean, let me show you. Okay, this works, right? Let's do no indentation, because something like C, this wouldn't matter, right? We have our, I mean, there's conventions you follow in terms of indenting, but you don't have to, right? Now, if I run this and hit save, my format doesn't save me because this is just not valid Python, so it can't even format this because it's just like, I don't know what this is. And sure enough, I run this and it says, oh, indentation error. It's saying, well, you have a colon here in this if statement, so you have to have then indentation after that. Okay, any questions? Now, I'll be honest, I remember looking at this and being so annoyed. I guess it's really particular as a young student or something like that. I'd be like, how dare you make me space my stuff a certain way? Like, I thought it was so lame that white space mattered, but now I've accepted it and it's okay. So it's okay to feel like this is silly, but it actually has some great benefits that people's code looks relatively similar. And it's okay, you know, who cares? Any questions on that? No? Okay, let's see here. Use a formatter, don't mix tabs and spaces. Yep, got that. Okay, let's see here. Where did I want? Okay. So another kind of weird idea of Python is its use of actually English words to denote comparisons. Or so we see here double equals, so that's okay. Phew, we got that. Let's ignore this for a second. Let's do like 5 and 10. So you actually use to do a logical and you don't use, what would it be in C? Double pipe. Sorry, that's 4. Double pipe. You don't do that. That's not a valid syntax in Python. You use the word and. I guess it's supposed to feel like more English-ish. Or you use or. Now they do have this operator, ampersand and or the pipe. Well, that's a bitwise or and. So they still got that from C, don't worry. But if you want to do a logical comparison, which is most of the time what you want to do, then you do an and or. The last one is not, also not. So rather than an exclamation point, it's the word not. So that makes it look like a function. So that's how you kind of cascade these things, and ors and nots.
It also is.
Oh yeah, okay, thank you. Yeah, is. Okay, there's more. Sorry, there is
It's part of an if statement. That makes sense.
So if 5 in a list of 1, 2, 3, print the list. Let's run that. Okay, it didn't print it out. So let's add 5 to the list. So 5 is in the list. So that's a really helpful one. Is it'll check in something for you. Now, clear, it's not doing anything magical here. I mean, it is maybe magical because it's English, but it's not like it's just like knows right away, but it has to search for that and actually try to find it, right? You know, it's using an optimized search to try to find it, but it still has to search. So if you had a list of 1 million things or 1 billion things, you did that end operation, that you wouldn't like be able to bypass the performance issues that go along with that. Yeah.
I actually have 2 questions. So one, are variables scope sensitive in Python?
Yes.
Okay. And then number 2.
No. Let's go over that. Let me show you an example of that.
Okay, and then the second question is, I noticed that the output seems like you put a new line character there, even though you didn't. Does Python automatically like
Yes.
send a new line to each
Yeah.
string?
The print function has, automatically adds a new line. That noise you can do end is equal to, and then that, and then you can tell it like don't put the new line for me. So you can see my output finished right here. That's a Z shell thing for doing. So there's the end. Or if we want to be crazy, we can be like, oh, let's do tons of new lines. Let's see what happens there. It's kind of handy. Okay, so let's talk about scope for a second. I think I should have probably prepared a little bit more for it. I did have one thought on that. So let's create this. I don't know. I have a certain style for doing Python programming. Other people might not like this. You could really do this like even is equal to true. So let's create this flag, this Boolean, where it's called even, and we're going to set it to true here. Let's print out even. So hopefully your spy senses are tingling a little bit, saying, wait, what's going on here? I just define a variable in here. I can print it out here. And the answer is yes, Python will let you do that. So let's run that. So I would say that's not a good idea most of the time to do that, if ever, because what happens if we get an odd input because we don't control this input, let's say, then it's going to crash and say, well, I don't know what even is because you didn't define it. Say, oh, let's get clever here and let's just say, okay, well then even is equal to false. And that works. So if you're careful when you follow every branch, then you can avoid that issue, or you could just say, well, let me just define it up here as the default case, and then you're fine. So that way, yeah, so even was defined in a local scope, but then it actually exists past it. So that can be a good thing or a bad thing. Okay.
I call that the no inferred latches style.
Oh, is that what it's called? Oh, I see.
220.
Okay. You might not think this is a big deal, but I think it's a big deal. Is what is a truthy value in Python? So you want to tell me what a truthy value means? So people take 330. Didn't we talk
We
about
talked about that this week in 330 for C, that anything non-zero is truthy.
So does anyone want to define what truthy means in a context of a programming language? Yeah. Yeah. Okay, yeah, so yeah, just in general, what it means is it considered a true value or false value? But what is it? In C, it's anything non-zero is true, zero itself is false. Python, it's a little bit more complicated. So let's bring up the REPL again. Let's try out some stuff. So what we can do is we can cast things to a Boolean. So this will tell us whether it's true or not. So we're casting bool to 5 to a bool and it's true. Okay, great. So integers. So far it's like how C is. A 0 is considered false and a non-zero is considered true. Let's try negative numbers. Okay, still true. Okay, so it's very much like C. But Python's much more complicated than C. So let's look at other things. How about a string? What happens for a string? Okay, true. So strings are considered true. Empty string is not. So anything, my general rule is anything that is empty is considered false. Anything that has something is considered true. Let's do a list. What's a list like? True. But empty list is false. Okay. This actually is helpful. You'll see these idioms going throughout Python of we create some list and we want to check to see if anything was create that list. List is that, and then maybe we have some logic to add stuff to the list, but maybe not everything's gonna get added. We say if list, you could just do that. Like, is list true? Does it have stuff in it? If it has stuff in it, then print it out. But if if it doesn't, then don't bother printing out. So you'll see that all the time. Of course, any object itself can override bool, what it gets cast to. So if you're using a complex object, then it's up to the person that created that. And hopefully they choose a good value. Let's look at what none is. False, that's what I'd hope. Okay, so those are truthy values. So anything that has something is true. Anything that's empty is considered false in Python. Okay, let's see how we're doing on time. Okay.
Maybe so if an empty list is false, then how do I check if a variable is an empty list versus none? Maybe you're going to talk about that. How do I check that something's none and not just an empty something?
So you could do, thank you. So if list is none. Is that what you're getting at? Okay, yeah. So you might say, well, this actually would work because none itself is a false value. So if you don't care between distinguishing between none and an empty list, then it doesn't matter. But if you do care about distinguishing, or if none is option, then it's the Pythonic way to do is none, not to do like equals none is. I forget why the difference.
Does it even work equals? I don't know if it does.
Yeah.
It works.
It works, huh? Okay.
But it's better to use is. If you never see equals none, it's always is none, but I can't tell you why. I trust conventional wisdom to.
Make the code readable.
Yeah, I guess it does. Okay, so let's go back up to this example of me defining even. Oh yes, thank you. Yeah, there are some that's kind of like, wait, shouldn't you put like a not right here? Like, that would kind of make more sense. That's how like the C is, C code, but it is not none. Is that what you're referring to, right? Yeah, so that's totally valid Python as well, is not none. And so that's where you kind of get into more like, make this sound like English, not kind of this weird order and stuff like that. There's a lot of niceties with Python that way as well. Just one more example, like 5, let's do, I got my num up here. You can also do stuff like greater than, like something like that. And that actually works in Python. It will do the right thing as you expect it to do. You know, in something like C, you'd have to do comparison and, comparison. You have to kind of chain it in the right way with parentheses. Here, this just kind of magically works. Lots of nice little English niceties in Python. Thank you. So let's go back up to this example, because this is a blessing and a curse. I think there's some cool things you can do with this, and kind of the ad hoc nature of Python. It's just like, oh yeah, just create a variable wherever you want. So you don't have to find the top. You don't, just can be handy sometimes, but it also can get you, can bite you pretty hard. So the perfect example, I remember I was sitting in my seat, ran Python as a researcher here as undergrad, and I had a long running task. I was running all these benchmarks and doing all this stuff, and it was literally taking hours to run. Let me just import time as that. So what will happen is because you have no compiler, it'll just happily start at the top of the file and interpret each line and go along. So let's say you have some long running task, and I'm going to simulate that by just adding a sleep command here. But imagine you're sitting here for an hour, and you wrote something wrong. Maybe it's an odd number, and so it's going to get here, and then it's going to print out even. Even's not going to exist, right? But Python does not tell you that, right? It says, oh, there's no syntax errors. I'm not going to compile it, so I'm not going to worry about it. And so here you sit for your hour waiting and for your output, and then, oh, you get this. So this highlights the importance of being careful and using linters, using IDEs to help you with this, because this will get you, I promise. No matter what, it'll probably get you, but it's just a long running task. But that's the nature of Python, that it starts at the top of the file and reads its way down and doesn't bother even looking at even until it gets to to line 13 and says, wait, what's even? Okay. Yeah, that's true. I guess it tells you line 13. Yeah. So you rerun it for another hour and then wait for the next one.
Okay. Do you have the new Microsoft Python thingy, Pylance?
No. Oh, maybe I do actually, because I saw a
Pylance.
pilot.
Pylance would catch this. Pylance is pretty fancy.
Yeah.
I thought it would underline and say this might be undefined when you use it.
Okay. Maybe we need to upgrade. Yeah, it should. Something should do that.
You could run Pylint, but I think Pylance, usually when you open Python, VS Code says, hey, we've got Pylance. Do you want to use it? But
Okay, so one more thing I want to talk about regarding Python is its multi-paradigm. So, I hope while I've been talking, if you don't know much about Python, doing a Wikipedia search for Python. That's where all great research starts, is Wikipedia. What's the common knowledge for Python, right now? And so you read all the great things about Python, and you'll see, wait, what is, there's Guido right there. History, okay, you'll see here, Python is a multi-paradigm programming language. What is that? So let me tell you what that is. And I think this is one of the reasons why I love Python. There's different ways of writing programming language, right? You've been indoctrinated with the class structure. Everything is a class, right? You have to create classes for the clock or for the dog that barks and the cat that meows, all the different things, always classes of everything. You'll also see functions like with C. Those are different paradigms, right? There's no necessarily one right way. There's other paradigms as well, like functional programming. And so Python supports all those different things. So here you haven't seen a function yet, right? I've just been kind of more what I call like scripting kind of thing, where you just kind of banging out lines of code and just seeing if it works. But let's say this is a really important function. Let's make this into a function right here. That is even is their indentation correct? And then we'll just do, we don't want to print anything. So return true, return false. Okay, everyone agree with that? So that's how you write a function in Python. I'm not going to go over the details of it, but you can kind of guess, in terms of that's the parameter. Great. So now we just wrote our first function. So we graduate from writing quick scripts to however we want, just doing whatever we want, the Wild West, to say, well, no, we probably have functions. These are reusable code, that's all important type of stuff. So let's just test it out, make sure I wrote it right. Is even 5? I gotta print it on the REPL. Let's try out a few other numbers. 7, I don't know, let's try it. 0. Cool. Sounds good. Oh, I should have done like 6. But okay, sounds good. So what that means, so now we create our function, but let's say a function is not sufficient. Maybe we start wanting to have a class. And so now we can quickly define a class in Python. And we're not going to be talking about file structure in terms of you probably want to break these down in different files, but you don't have to in Python. That's another reason why I like it, is because you can just grow. You say, well, let's define a class here, like a number class. And then classes themselves have a kind of interesting way of being written in Python. Let me just write this out and explain some stuff. Okay. Def is Ethan. Self. And then let's duplicate this code here. Let's actually write it a little bit better. Return self.num %2. That's equivalent, right? We're checking to see if it's true and then returning true. It's kind of redundant. We can actually just return that whole structure, and so we can be a little faster there. So here I've created a new class. I give it a number, and I've created this is the initializer. It's an int. Remember, it's a dunder, double underscore. So that's kind of a special thing. It's how you create the object. And it takes in one parameter. Call it num. Now here we got this self thing, and this I remember really throwing me off when I first learned Python. What is this self? This is so weird. So what this is doing is to keep, I don't know how to explain it.
You've done C++, right? Isn't it just this in C++?
I guess it's kind of like this, but nice thing is,
required. I think it's required in Python, right?
yeah, it's required, but the name itself actually is not required. So it's a convention to call it self. But so let me run this real quick. So let's not use the function version anymore. Let's do num is equal to number. So let's initialize it. We don't have to use the word new or anything like that. 5. We can do print num dot is even. Don't ever write this class. This is a bad example. But okay, so there we run it. So what's happening behind the scenes is, but like, wait, I didn't pass the parameter to is even. I just kept it empty. So what's happening behind the scenes, let me write a comment here, is that num.isEven is getting converted by Python into number, the class dot is even, and then passing the object num into it. And so anytime you call a method on a class, it's going to automatically put that object you called on it into the first parameter. And so convention, once again, is to call it self. We can call it whatever we want. We could call it X. Don't do that, but you could. And it works. It's just a parameter that's just automatically giving to you, but no to know what you're doing here. So just call it self. So that's kind of a weirdie of it. And there's good reasons for it. It actually helps keep this, it's actually just a function that's embedded, but it's nothing special about it, which I like. Yeah.
Does any function in there have to have self as the first argument passed in?
It doesn't.
If you don't have one, it's going to error because it's going to.
Let's try this.
Call it with the wrong number argument.
Yeah, so let's not call, there's a compile first of all, right, is a question. And I think it'll compile fine. I think that it becomes,
When you call it, it throws an error though.
yeah, when I called it, definitely it throws an error because here it's saying, well, hey, even takes no arguments here, but provide an argument. So we were essentially calling this.
Self, or whatever you want to call it, ideally self as the first argument to every function.
Yeah.
If you have others, you put them after type of thing.
Yeah, so you do def is odd, is that what you're asking? So you have to put self here as well, right? Is that what you're asking?
Yeah, but if you want to pass out a parameter, you just have to have.
Oh, yeah, okay, yeah, let's go. Yeah, we'll see that. So another number here, another, all sorts of stuff here. Okay. And there are a few other kind of tricky things you can actually put and make it a class function instead, but we won't go over that. Okay, so any questions on that? Any questions on that? Okay, we're out of time. Let me go over one more thing, and then we'll be done for today. Is that
I
okay?
guess one thing that's worth noting is one thing that trips me up is, this init is, I guess, analogous to a constructor in C++. I don't, do we call it a constructor in Python? I do, but I don't know if that's the correct term. Anyway, normally when you make a constructor or when you declare a class, you list all your members. But in Python, we could make new members on the fly. I don't know if you want to show that or not, but it's like in your other function, you could add, in your isEven, you could add a new member essentially.
Yeah, whatever, I mean,
It also means if you have something called foobar X and you accidentally type foobar, it'll happily make a new one and accept your typo and can really frustrate you.
I mean, it's like, yeah, it's Wild West. You can create variables anytime you want. And so maybe you meant, and yeah, maybe you meant this to be a self.num, maybe maybe you put n instead of an m, it'll gladly accept that, and then it'll just come, fail when you actually get to that code. But you can also create new variables as well. Yeah.
So having the self dot variable stuff to make member variables and things, is that giving it a sort of scope to just that object?
Yeah. So it's attaching it to that object.
It's kind of making a scope where there isn't one normally.
Yeah,
That's
this-
an object.
Scope does exist for classes.
Okay, interesting. What if you put one that didn't have a prefix of self in there, just like a regular variable that just gets assigned? Does that make that a global?
Local.
Local.
This goes away at the end of that function.
There are ways you can
interesting.
do tests.
Functions have scope.
Yes.
So if you're inside his little down below, the first isEven we created, go down below there, line 16.
Yep.
You can declare variables inside that function and they are local. You will not see them outside.
Okay, good point. Yes.
As opposed to where he defined one inside an if clause and then it was visible below here. That's a true local variable.
Yeah.
So it's kind of like this in C++, right? Referring back to the object.
Yeah.
Okay, so the self ones are the ones that are stored by the class.
Okay, so self, yeah, it's like this. But I like it in the way that it's actually explicit, because this magic keyword, where did it come from? It's part of the language, but here the self is just a variable that we just happen to name convention self, but you can trace it back to, okay, it came from this parameter right here. So it's actually a little more explicit than other languages.
So, yeah, so when he had the if statement before, it wasn't in a function, which is why it became a global event.
Are global variables on your script there?
No.
Things to talk about? No? Okay.
Should we talk about them? What do you want to say?
Should we?
Well, you got to do something to see global variables. They are not visible inside a function. Show them how.
Yeah, so you're saying, let's see here. So let's test it out.
That's what I meant to say, that.
So let's comment this out. Print, so let's just define even is equal to true. These names are terrible, I'm sorry. It's good even, but whatever. Let's get rid of this because okay. Where did I put that? Okay, is even 5. So there, it printed out. That's working fine, but that's inside. When you get the,
Did this change?
Yeah, I was just going to say, it shouldn't have worked according to my view.
I had to type global even at the start of the function.
Yeah.
no,
No. It's only if you want to set it, not.
that's right, yeah, that's what
Oh.
it is. So
You can read it anytime you want, but if you want to change it,
That is interesting.
that's right, yeah. There's kind of weird stuff like this, yeah, thank you. Okay, so let's do even is equal to true. Let's actually set it, and then even is equal to false. So here it's gonna, you can actually kind of tell, see, it's kind of telling me, I think, because notice how it's not as white. It's kind of grayed out, it's saying, I don't know what this is.
it's saying this is throwaway code. It has no effect. You're making a variable that you're not
I'm
using.
not using later on, yeah.
It doesn't recognize that this is the global variable that you're assigned
It's
to.
called creating a local variable from the
Yeah, so here I'm using the global variable, and then I don't want to show that.
Oh, that's even weirder, huh? It's looking ahead and saying, oh, you're going to use this later, so you must not mean the global here.
Okay, so there. So yeah, it doesn't know I'm using the global one. So you do global even. You have to declare that at the beginning of your function. You say, hey, even, don't create it for me in the scope of my function. Use the global one.
you shouldn't use global variables anyway, but if you adopt code that uses them, just,
It's a non-local, I forget what.
I've never seen that one.
It's a new word, but I forget how to use that one.
So non-local for nested.
I love Python.
Oh, yeah.
Oh, yeah.
I mean, so Python changes the way you think. I mean, and you see this a little bit in 3.3 that functions can be passed around just like integers, just like anything else. I mean, you got terrible syntax in C with all these function part stuff, but in Python, you can create functions and pass them around like anything you want to. And you can have, why not have a function inside a function? Is odd. So what my the one, check to see if it's odd, and then do return not is odd. How's that for you, right? So that's, yeah, and then if you got a global variable or a local variable in that scope. Yeah, so anyways, you can nest functions inside functions. It's the Wild West. I like that. It's like a blank canvas is how I should say it. Blank canvas, and you can destroy yourself or build. Okay, I think I'm out of time. This is getting past. There's so many more things to cover. One more thing. Dynamic typing. We've been kind of playing around that a little bit. I've shown you that list can contain lots of different things in it. But I just want to make that clear. Python is dynamic typing. It doesn't matter what a type is. You don't ever define what the type is. You know, if I even, it can be a Boolean here, and it can be an integer somewhere else, and you can redefine it wherever you want. That's a good thing and a bad thing. Yes.
There are cases where you would want to be able to force it to interpret as a certain type and do that in some kind of math or other thing, and you have to explicitly tell it so it doesn't do its automatic one that you don't want it to do. Are there cases where that's the situation?
Yes, I'm sure there is. I mean, I'm trying to think of.
Is it that hard to do that? Like you have to kind of wrap around.
No, there's times where you don't want to interpret that. I mean, example, this was an issue with Python 2 more like where if you did, I'm going to forget the details, but if you did like 5 divided by 2, it'd say, oh, those are 2 integers, and sort of cut it off. And so what you'd want to do is actually, I don't want it to cut off, so I need to make this a float, first. So weird things like that. So sometimes it does backfire on you.
Is that less of a thing 3?
Was that?
So you said that was more in Python 2. Is that not a thing in
Yeah, Python.
just default to float?
It default to float. Do I have Python 2 here? No.
You should pull up your old diagram.
Yes.
Is that a way? Okay, yeah. Do you?
You do have to be careful because I've had things like, for instance, where I have things like binary, and it's like, if you're doing stuff with bytes and stuff, and you don't have a bytes type. So while it's easy to set stuff dynamically, certain functions do require that it is a certain data
Yeah.
type. So and that can be obnoxious to keep track of. So that's one thing to look out for is, what type is this? And that's when IDE comes really handy of okay, what type is this actually supposed to be? Because while the variables can change type really easily, sometimes the operations you do on those variables require a certain type.
Okay. Yeah. Okay. So what you get from dynamic typing, which I think is a great benefit, is something called duck typing. Anyone heard of duck typing? Look at the source of truth and knowledge, duck typing. It's a real word. So it's using the duck test. If it walks like a duck, if it quacks like a duck, then it's a duck. The same thing with Python and its types. If it has a method or a function attached to it, then it is what it is. I don't care what it is, the actual object is. So I feel like they describe it pretty well. With normal typing, suitability is determined by the object's type. So in C, it has to be an integer. That's how you determine if it's capable of it. But duck typing, its suitability is determined by its presence of certain methods. So if it has dot odd or is odd, then it's a duck. You don't care. As long as it has certain parameters or certain methods or properties to it, then it can just act like that. So example of this is, let's go REPL for the sake of time. Get the length of something, you use len, I don't know why in Python, that's just how it is, length of a list. So we expect this to return 3, sure enough. But we can also, what else has a length to it? A string. So there, so that's example. So you don't have to know what you're getting into it. It's called length, and if it supports the length operation, then it's going to work. Of course, it doesn't always work. You pass that and say, well, no, an integer doesn't have that. Another example is this, A times B. Do that combine, let's print first, print, combine, try and go too fast. So combine's probably not a good name, we should have done like multiply. So we do that, okay, it works well enough, I expect, but what if we do this? Hey. You can multiply a string in Python. So, ABC times, let's do times 100. Just make it right. So repeat string over and over again. It's actually a very handy feature to that. What about a list? Yep, same thing, over and over again. So that's great. So yeah, we can multiply those things, but gotta be a little bit careful because what if we do that? So what happens if we add a string to a number? I mean, if we added, sorry, that's a string, test, adds them, concatenates them together, right? That's cool. So you just learned something there. 5 plus 5 should hopefully add them, right? But if we add test to 5, that maybe you might think actually works. Actually, it doesn't. JavaScript it does, but not in Python. You can't combine a string and an integer. So this is the duck typing is that it works until it doesn't, I guess. And so that's the blessing. It does bite you sometimes. There is something called type annotations. It's a relatively new feature. It's an optional feature. You can actually see it happening right here. The type that B can be is any, which is the keyword for any type. I could say this needs to be an int, and this needs to be int as well. There's special syntax for this. I barely know it. I will just do one more thing.
They added that though. That's cool.
It's worth looking into. It's kind of a new thing to do. It's completely optional, which I like about Python. It's completely optional, so you don't have to feel like you do it. There's just, and in fact, actually, if you totally violate it, it doesn't even care. It's purely, I just said int. It's more of a tooling thing. I could have run some command beforehand, and it would have honored that command and optimized it somehow. So it's actually something that's not done at runtime because it doesn't want to add any penalties to the performance to do all this checking. It actually happens more like you would want to check it ahead of time. So if you had a large code base and you want to make sure all your objects worked out well, you could be doing this and then you could work. But it's really nice because you can have one file that does it, one file that doesn't, you can just mix and match. And so it's a great thing if you're interested in that. Okay, that's all I have time for. There's a lot more interesting things and we'll talk about it a little bit next
So how much time are you going to take on Wednesday?
as little as I need. As
Well,
little as I need.
but how much more have you got to do?
I mean, I just want to go over
You
this.
go for weeks, right?
Yeah, I can go for weeks. But no, we'll cover, so your homework for this week is to write a Python script. I'm not going to tell you what the Python script is, write it, mess with it. Just open up Python, run it, stuff like that. But tomorrow, I'll give you more specific assignment about something cool to do. Is that okay?
I'm going to take around between 20 and 30.
Okay, cool, yeah.
So if you take between 20 and 30, we don't go over, but if you go over, great, because
No.
this is,
Yeah.
you guys can't pay for this good of instruction, by the way.
So
He's a master.
just a thought is, this is all great and I showed you cool stuff, but I don't know, you ever feel like this at the end of your undergrad, you're like, I'm tired of writing calculator apps. I'm tired of writing things that just run in themselves and they're done. You want to interact with the world, right? And that's actually what got me into networking is I wanted to interact with the internet. I wanted to grab data from places and manipulate it or graph it or do cool things. And so that's what we'll talk about next lecture is how to actually interact with the world through files, through command line arguments. That's a very important skill if you're an engineer. And then through the internet as well, just real quick. And then that'll be your assignments actually. Okay, thank you guys.
Ask.